Is life an amazing phenomenon exclusive to our planet? Is there life beyond Earth? Humankind has always asked itself this question, but no answer has yet been found. However, thanks to the latest extraordinary advances in astronomy, it appears that we are closer to solving this mystery. State-of-the-art space probes explore planets and moons in our solar system, while sophisticated telescopes scan the universe looking for answers. The results of the research are amazing.
One of the big triumphs of astronomy in the last 2 decades is to show the majority of stars have planets. There are planets all over the place. There are more planets than stars.
These findings have been made possible thanks to the NASA space probe Kepler, whose launch in 2009 marked a milestone in the search for life beyond the boundaries of our solar system. We now know that in our galaxy alone, there are billions of Earth-like exoplanets. Given the vastness of the universe, with more than 100 billion galaxies, it is hard to conceive that somewhere there is no Earth-like planet that can harbor life. Finding it is simply a matter of time.
It's a game changer. It changes what we think about the possibility for life somewhere else. Exoplanets and extremophiles, 2 game changers.
This leads us to think that in apparently harsh environments in our solar system, there is now, or may have been, life. We may find some form of life in the strange methane lakes of Titan, in the oceans hidden under the mysterious icy surface of Europa, in the gigantic geysers of Enceladus, or in the desert plains of Mars.
The second genesis within the same solar system implies that life, the origin of life, is a likely event.
We don't know if the discovery of life will happen first on one of these moons or planets in our solar system, or on an Earth-like exoplanet. But what we do know is that we are closer than ever to unveiling one of the greatest mysteries of nature, whether there is life in outer space. Life, an unbelievably perfect combination of elements able to create living matter. Possibly the biggest mystery of nature. A combination of matter that shows certain attributes that include responsiveness, growth, metabolism, energy transformation, and reproduction.
We don't yet know exactly what life is. We don't have a working definition. Probably my favorite definition is that life is some sort of chemical entity that is self-enclosed and is capable of Darwinian evolution by natural selection.
Some studies state that life may have begun in Earth as early as 4.1 billion years ago. That is still only slightly younger than Earth. A question arises immediately. Is life an exclusive phenomenon of Earth? There's no easy answer to this question. The chemistry of life, begun shortly after the Big Bang, 13.8 billion years ago, during a habitable epoch when the universe was only 10 to 17 million years old. life may have emerged independently at many places throughout the universe. Or life may have formed less frequently, then spread maybe by meteoroids or comets between habitable planets in a process called panspermia. In any case, complex organic molecules may have formed in the protoplanetary disk of dust grains surrounding the Sun before the formation of Earth. According to these hypotheses, this process may occur outside Earth on several planets and moons of the solar system, and on planets of other stars, the so-called exoplanets. Since ancient times, humankind asked itself if we are alone in the universe, and if there is life beyond Earth. Those questions may not be easily answered. However, they have always fascinated us.
Astronomers have been interested in the question of life beyond Earth for a very long time. I mean, we can trace back through the ancient Greeks and Romans and Chinese writings speculation about life beyond Earth.
The main issue to search for life in outer space is to establish what are the life support conditions. A source of energy, such as from a nearby star, is needed to drive endothermic or energy-absorbing reactions. Raw materials, predominantly carbon, build and form organic molecules.
So the building blocks of life on Earth, and we know them, there are carbon, hydrogen, oxygen, nitrogen, and others. They are what we are looking on other planets to look for life as we know it.
These building blocks for life, at least as we understand it, are ubiquitous.
Also indispensable is the presence of a liquid or very dense gas as a solvent for biochemical reactions to occur quickly and stably. Liquid water, the life-sustaining universal solvent, at least on Earth, entails certain atmospheric composition and temperatures.
In order to have a habitable environment, you need three things. You need liquid water, and you need organic material, and you need energy. And there are a number of places in the solar system where all three of those things are thought to exist.
Now we already know the key conditions for supporting life. A question arises immediately. How many planets or moons in our solar system meet these conditions? Considering that one of the key prerequisites for extraterrestrial life is the existence of liquid water, there are three candidates in our solar system to have liquid water on its surface. The planet Mars, the Jovian moon, Europa, and the moon of Saturn, Enceladus. Besides Mars, Europa, and Enceladus, which might have liquid water on their surfaces, there is another candidate for supporting life in our solar system, Saturn's largest moon, Titan. Until 2004, Titan remained a great mystery to astronomers, as a dense, opaque haze prevented understanding of its surface. On 2004, the spacecraft Cassini reached Titan and released a small probe named Huygens. That would change everything. These are the images that the Huygens camera recorded as it descended through the haze. Titan's landscape is very similar to Earth's, with mountains, valleys and plains. When the probe touched down on the surface, it revealed something no one expected. There were pebbles everywhere, similar to the rocks of riverbeds on Earth.
When you're looking at those pebbles, yes, they are rounded pebbles and they have been rounded by torrents and rivers. But they are not rocks in the sense that we understand. They are actually water ice, so hard that it behaves like rock.
How were these rocks eroded? Is there liquid water on Titan's surface? At minus 180 degrees Celsius, water should be frozen solid. Cassini's radar had the answer. It showed us that Titan's surface has hundreds of lakes.
The big difference, though, is that they are not made of liquid water. They are made of liquid methane.
These two hydrocarbons on Earth are volatile gases, but with Titan's chilly temperatures, they are liquid.
The atmosphere of Titan has methane and ethane and other organic materials that provide a very different kind of chemistry, but a kind of chemistry that is reminiscent of what Earth very possibly looked like before life was abundant.
All these worlds are very far away from the heat of the sun, so they are extremely cold, and some of them are exposed to very high levels of radiation, as they have very thin atmospheres. Therefore, their environments are quite hostile to life. However, life might have found its way.
We also now know about extremophiles, forms of life that live in environmental conditions that when I was a student, I was told, impossible. Can't have any life there. It's too hot. It's too cold. It's too acidic. It's too basic. Too much pressure, too much radiation. They have evolved to thrive in those conditions. So this whole new field of study of extremophiles, it's a game changer. It changes what we think about the possibility for life somewhere else.
Extremophiles such as bacteria that live in high temperature, toxic, deep-sea hydrothermal volcanic vents on Earth offer insight into life that could have developed on other planets that mostly share such extreme, inhospitable environments, which also can include freezing temperatures and minimal sun exposure.
This gave us such a different view of actually what was necessary for life to survive. And all of a sudden, the solar system totally exploded. The horizon of what we call habitability and habitable environment completely expanded in ways that we could not have expected at all.
The chances of finding life on any of these remote worlds in the solar system are now much higher. Finding it is simply a matter of time.